forget to like and subscribe this channel.
Now we will continue with the second part of lecture 2. So we will study a new subtopic for this part, which is liquid. So in this subtopic, you should be able to relate the properties of liquid to intermolecular forces, molecular arrangement, molecular motion in explaining shape, volume, surface tension, viscosity, compressibility, and diffusion. So there are few factors which affect the general properties of liquid, and they are arrangement of particles and intermolecular force. So for arrangement of particle, the liquid state is an intermediate between the solid and gaseous state. And in a liquid, the particles are very closely packed as compared to the gaseous state, while the intermolecular force is the strength of the intermolecular forces between molecules. So the intermolecular force for solid is stronger compared to liquid, and the intermolecular force for liquid is stronger than gas. So the types of forces between molecules in liquids are van der Waals forces and hydrogen bonds. So if we compare between the three states of matter, so let's look at the first one, which is molecular arrangement. So for solid, the molecules are very close together and neatly arranged. And for liquid, the molecules are still close together, but not neatly arranged. It means that the arrangement of particles can be changed. While gas, the molecules are far apart from each other. For intermolecular force, for solid, it is the strongest. For liquid, weaker than solid. But gas is weakest, which is almost none. For molecular motion, in a solid, molecules can vibrate but do not move from their position. For liquid, molecules are able to move around. But for gas, molecules are moved about very fast in all directions, meaning that they are free to move around. Now let's look at the general properties of liquids. So liquids have definite volume, meaning that the intermolecular force is strong enough to keep the liquid molecules together. And it has indefinite shape, meaning that the intermolecular force is not strong enough to hold the molecules in a fixed position. It means that it can change the shape according to the volume of container. Now let's look at surface tension. So surface tension is the amount of energy required to stretch the surface of a liquid by a unit area. So if we look at this diagram here, if we have an object on a surface of a liquid, so the liquid molecules will stretch the surface in all directions on the surface. So liquid molecules at surface are pulled downward and sideways from the neighboring molecules, but not upward away from the surface. It is different from an object inside the liquid. So let's look at this paper clip here. Why can it float on top of a liquid? So actually this is what we call as surface tension. The surface tension of liquid keep the clip to float on the liquid. So the intermolecular force will pull the surface molecules into the liquid, and it causes the surface to stretch and tighten. The stronger the intermolecular force, the higher the surface tension. Now let's look at viscosity. Viscosity is resistance of liquid to flow. The greater the liquid's viscosity, the more slowly it flows. So now let's look at honey. So it has high viscosity. So it means it is very hard to flow compared to liquid with low viscosity such as water, juice and oil. So viscosity is depending on the intermolecular force between the molecules. The stronger the intermolecular force, therefore the higher the viscosity, the harder it is to flow. And the last one is compressibility. Can we compress liquid? So actually there is very little empty space between liquid molecules because the molecules are close to each other. So let's say we have a string here and we close the end of the string and we insert liquid into the string. So actually we cannot push the piston anymore because of the empty space in the liquid which is very small. So liquid has low compressibility. And the last one is diffusion. So liquid can easily diffuse and mix with other liquid. So diffusion rate of a liquid is low because liquid molecules are close to each other, has lower kinetic energy than gases, and the stronger intermolecular force slow their movement. So let's say we drop an ink into the glass of water. Therefore, the ink can actually diffuse into the water, but it takes quite a time for it to diffuse completely into the glass of water.